Assalamu alaikum. Now we'll see the Proteus simulation. So if I start this simulation, at first we'll see some messages here. We can actually give any message, right? Like we can also include our team members name here. So if I just start this one, let's uh, hide this part for for now. Okay, start it again. So at the beginning there are some messages, and now it is asking me to give the minimum temperature. So let's give minimum temperature to 8. But to enter 8, actually always we need to give some 2-digit inputs. Okay, if you want to give input 1, then we need to first give 0 then 1. So to give input 8, we need to first give 0 then 8. Okay, now median temperature, let's say this is 14. Then maximum temperature, this is 44, and critical temperature, this is 50. Let's say this is 56. Okay, now you can see that here temperature is written 1 degree, but it is showing 2 degree. So there is a bug in the software. It cannot actually show the even odd values. Okay, yeah, 1 will be shown 2, and 2 will also be shown 2. Okay, then 3, 4, 4 will be also shown 4. Okay, now t is less than t minimum. See, our motor is totally stopped. And in software there is another problem. When from actually when the motor is running at full speed, if we stop our motor doesn't instantly stop. Due to inertia, it will gradually stop. Okay, so what is happening, the ADC is continuously see, continuously it is giving output to our microcontroller. So if I just, if let's see, if just I increase this one, see the values here changing. Okay, so now t is less than t minimum, and this is the LED bar. Okay, so here one part is connected to this, these 3 pins are connected to the microcontroller, and these 3 pins are grounded. These are positive pins and these are negative. The buzzer is, one pin is connected to the microcontroller and another pin is ground. If we give, actually in software the buzzer is active high. So what does it means? If we give high voltage to the buzzer, it will be on, and if you give low voltage, it will be off. But in hardware the buzzer is active low. If you give low voltage, then it becomes high. So to match with soft hardware, we have used a NOT gate. So now if I give low voltage here, it will be high and the buzzer will be on. Okay, so and this LED, if one LED is one bar is showing, then it is in low speed, 2 bar it is medium speed, 3 bar it is high speed, and no bar is shown, that means the motor is stop. Okay, now let's increase the temperature. Okay, 6, then 7, it has become 8. Okay, so see, the motor is running at a low speed. Okay, so now let's what I can do, I can see the digital oscilloscope to see the pulse. Okay, that is actually going to the in one pins. The enable pin is always positive 5 volt, but in one pins we are actually giving a pulse. So we will see the wave shape of this pulse, and in two pin is grounded. And here you can see the, like the pin out, there are two VSS. Okay, one VSS is for the power supply of the motor driver, and another VS is for the power supply of the motor. We in software we have made both of these 5 volt. In hardware actually we can control this one, we can actually use higher voltage to motor, but in case of our project we have used always 5 volt. We are not dealing with higher voltage. Okay, so we'll now see this wave shape. Okay, so let make the temperature again less than see, this has become 0 volt. Okay, this has become 0 volt, 0 volt. And now when we just see, now we are getting wave shape. Okay, for 50 more, almost 50% time it is 5 volt, and it is set, and the rest of the times it is if this is our time period from here to here is our time period. So from more 50% part it is high, and for 50% part it is low. So let's increase the temperature and go beyond T medium. Okay, so if I increase 10, 11, 13, 14, okay, see, the positive part now increased, positive part increased, and negative part, zero part is a bit less. And you can see uh, now at is in running it stage 2, two LEDs are now turned on. Okay, two LEDs are turned on. Now let's increase the temperature more. So see, from pulse now it has become always high. Okay, so to run the motor at maximum speed. And now let's go beyond T critical. So here in this part, see, three LEDs are now running. Okay, and now we'll go beyond T critical. See, our buzzer is also working, and all the LEDs are turned off now. Okay, so let's stop this. So this is the overall circuit. And in the I have already mentioned, in the hardware we don't need this WR pin. And let's discuss the pinouts a bit more. Okay, the LCDs are connected to port 2, the keypads are connected to port 3, the ADC is connected to port 0, and this temperature, actually this is coming from where, the sensor. Okay, this is our sensor. Okay, we are manually changing the temperature, there is no automatic function here. uh, and the motor driver, here the out 1 and out 2, in this part the motors are connected. See, this is the motor, out 1, this is connected here, out 1, out 2. Okay, actually I have not mentioned that the motor speed actually changes, right? See, so we need to first enter the temperature. Let's say 0, 6, 1, 5, 4, 0, 59. Okay, oh, it didn't input. 0, 6, 1, 2, then let's say 4, 0, 4, 0, and critical temperature 6, 0. Okay, see, motor is running, motor will go to its maximum speed. Okay, yeah, this part is showing the RPM, rotation per minute. So if I go below 40, see, motor speed is decreasing. Okay, okay, and if I go below 12, see, motor speed decreased more. And if I go below 6, it will gradually stop. Okay, it doesn't stop instantly, it is gradually stopping because due to inertia. In hardware it will directly stop. Okay, so here I was, the motor out 1 is connected here, out 1, out 2, and this out 3, out 4 are for another motor. Okay, this enable to in 3, in 4, these are another motor. We can actually control two motors at a time using this motor driver. This is L29D motor, 93D motor driver. This is called a dual bridge motor driver, because actually we can control two motors, so dual bridge. And ADC 0804, dual edge bridge, the bridge is called dual edge bridge. The ADC 0804, this is the analog to digital converter, and the name of our LCD is LM016L. Okay, LM016. and this is the LED bar graph. Okay, and this is the buzzer. So here is this. Uh, thank you.